So today we are starting a new topic, which is subtraction of a vector, which is also known as vector difference. Vector difference. So subtracting of vector is basically like addition of vector, but a little bit different. So to start this off, let's write something, which is subtraction of a vector, subtraction of a vector from another vector is same as that of addition of negative of a vector with another. So what it's basically trying to tell you is subtraction of a vector is very much kind of like addition. So there is a condition or why it is subtraction, but it is meant to be addition. It's basically addition, but a little bit different. If you know algebra, so normal algebra, let's say 1 plus 3. So 1 plus 3 is addition, right? And you would say 1 minus 3 will be subtraction. But subtraction can also be written in terms of addition, which is 1 plus minus 3. So it's also very similar like this in vectors. Addition and subtraction are basically similar, so they are very similar, so they are two halves of the same coin. So that's what I'm trying to say. So even with a plus sign there is going to be addition, even with a minus sign there is going to be addition. So now to understand this, let's look at a picture, and I think this will make it much more clear for us. To understand this, I'm going to take two vectors. Let's say this vector is vector A, and I'm gonna make it white and a lot more thicker. And let's say another vector, which I will make blue. So let's take that, let's make it blue, and let's call this vector vector B. So we have vector A, though this is vector A, and we have that this is vector B. So if we created a parallelogram that goes from here, so this diagonal would be the resultant, which is vector A plus vector B. But we are trying to get vector A minus vector B. So in order to get that, what we must do is, we know that when we rotate a vector by exactly 180 degrees, it means that it is a negative of the vector, right? So I'm gonna take this, I'm gonna flip it around. Sorry, not like that. Let's see, how can I flip it around? Let's make it a little bit different shade of blue so that you know that it's different. Let's say if I flip it around 180 degrees, then this is not gonna be vector B anymore, right? It's gonna be minus vector B, since we change the direction by exactly 180 degrees. And now let's create a parallelogram out of these two vectors, so this dark blue and this white vector, like this. Let me make it much more clear by making them dotted lines and a lot more smaller as well. So let's say you have this. Okay, so as you have this, then the resultant that you get from going from this diagonal is gonna be the resultant. Yeah, it's gonna be a resultant, and the question is, what kind of resultant is it gonna be? And it's actually gonna be, so let's write it. I'm gonna write it with a red. So the resultant is just gonna be vector E plus vector B, but in this case it is not vector B, it's minus vector B, so it's gonna be minus vector B. So this is why we are saying that this is basically like addition, because you got this. As you can see, it's a plus something, so vector something plus vector something. As you can see, this is like addition. So let's go back, and this is basically like this. But you can also write it in normal format, which is vector a minus vector b, and this is vector subtraction. So we basically got everything that we need. Now let's just do a few things to make this much more clear. We know that the angle between vector b and vector a is going to be theta, and theta is going to be this angle since it is connected by tail method. And we know this straight line has an angle of 180 degrees, which means if you take just this part right over there, so I take this part, it's gonna be 180 degrees minus theta, right? Since the whole angle is gonna be 180 degrees. And also let's say that this angle, so the angle between the resultant and vector e be phi. So if you remember vector addition, we did the same thing. And so we have this. And also let's name the corners as well. So let's name this corner as O, this as P, this as Q, and this as S. So as you can see, this is basically vector subtraction. Now we're just gonna write this much more formally and be much more find equations that satisfy this thing. So let's write, which is, let us consider two vectors, vector A and vector B. Let theta be the angle between them. So we already did this, right? So now if we have to subtract vector B from vector A, then we can write first of all, I'm just going to write it in the way that you must write it, which is vector A minus vector B. But you can also write it in this way. So vector vector A plus bracket minus vector B in parentheses. So this is the thing that we have. Now we have to talk about what did we do. So I'm going to write this in another page. So I'm going to write that once more. Vector A minus vector B, which can also be written as vector A plus minus vector B, right? So to understand this, so this is basically like saying the first vector, so the first minus vector B is obtained by reversing the direction of vector B, and minus vector B is added with vector A according to the law of vector addition. So that's why we are saying that this is addition. So this is basically glorified addition. So now we need to find the magnitude, right? We need to find the magnitude and the direction of the of this. So in order to do that, we're gonna write this on another page. So now the magnitude of resultant is gonna be, so let's remember the normal formula, which is resultant equals to square root of a squared plus b squared we are not writing minus b squared, even though that will lead to the same thing. It's because magnitude is always positive, and magnitude meaning the length, so the length is always going to be positive. That's why we don't need to write it in minus sign. And plus 2 times ab, that's why there is no minus over here, since magnitude is always positive. Now we have cos theta. So cos theta would be the case when the resultant was coming out from here, but we are taking these two vector, right? So since we are taking these two vector, we must take the angle between these two vector, and the angle between these two vector is simply 180 degrees minus theta. So this means it's gonna be 180 minus theta. So this is in degrees, and let's put this right over that. So we have this, right? So you can write this as 180 degrees minus theta, or you can write this as 180 minus theta degrees, or you can write this in multitude of ways. So there are many ways to write this. It depends on how you have described the case. So in this case, if you go back, we have described that theta is the angle between vector A and vector B, which means theta is already an angle. That's why this would be the correct way of writing this. But if you were to describe theta if you were to describe it like this, theta degrees, then you should have written it in different ways. So I'm just telling you, not that important. Important if you're trying to do this very seriously, but we are just trying to learn this. So cos 180 degrees minus theta is basically like minus cos theta degrees. Sorry, minus cos theta, which means the resultant that we get is going to be square root a square plus b square minus 2ab cos theta, since cos 180 degrees minus theta is basically minus cos theta. So we have the equation that gives us the magnitude of the resultant. So this is important. And we did not derive this by using the triangle law or parallelogram law by the original method, because it's the same thing. So you would be doing the same thing. So rather than doing the same thing, we are going to use a principle of factor addition, and we are gonna do that. So let's call this equation 1, since this is the first thing that you must know about the resultant. So equation 1 gives the magnitude of resultant, right? But we are gonna specify what's the resultant. In this case, the resultant is vector A minus vector B. But a point that comes across over here is that this value might be, this is not the magnitude, this is the vector. So this is the resultant vector. To get the magnitude, you must put these bars over it. That's why we need to keep these bars. Now again if phi or phi, sometimes I have heard phi, but I think it's phi, be the angle made by vector r and vector a, then we have, so if you remember the tan formula, which is tan phi equals, so we are making this with vector a, so a will be over here, so b will be over here, then sine theta by cos theta. But instead of theta, we have 180 degrees minus theta, so this will be 180 degrees minus theta divided by cos 180 degrees minus theta. So now we are gonna use these things. So sine 180 degrees minus theta is just sine theta, so it does not matter however you keep it. You will learn this more about math, that's why I'm not going too in depth on these, but that's what you get. So it's gonna be b sine theta, since it's not gonna keep the minus sign or anything, it's gonna be sine theta, and cos 180 degrees minus theta is gonna be minus cos theta, which means we get a minus b cos theta, right? So you have this. So this means phi is gonna be tan inverse b sine theta by a minus b cos theta, right? So I think this is pretty clear. If you know what occurred from here to there, if you know that much, it's going to be very easy for you to understand. If not, that's going to be a little bit harder. So we have this, and this angle is also responsible to find the direction, right? So this is also very important to find the direction. So let's call this equation number 2, and let's put the box around it. Now we know that the equation 2, so let's write that as well. So equation 2 gives the angle made by vector r and vector a. So this is what the angle is made. So if we know this angle, so I'm actually going to keep it over there. So if we know the angle, we can definitely find the direction of vector r with respect to vector a, and we are assuming that we know the direction made by vector a. So now that's basically subtraction of vectors, but let's talk about a few notes. So there are going to be a few notes, and I'm going to tell you about them since they are kind of important. So let's say we found vector a minus b. So let's say to find, if you have to find vector b minus vector a, what would you do? So to find this, we know that vector b minus a is basically as vector b plus minus vector a, right? So we know this. So since we know this, what we can do is I'm gonna copy this top part at least. So let's bring it right over here. Let's move it, and let's delete the things that we don't need anything right now. So let's say this is vector a, right? And this is vector b. Let's move it more towards the left. Okay, so let's say we have this, right? Now we need vector b, so we have vector b, and we need minus vector a. To get minus vector a, we just need to rotate the direction of the arrow. So to do that, I'm going to use this. So we have rotated this, and I'm going to use another color, let's say this gray, to separate it. And this gray one is going to be minus vector a, right? So this is minus vector a. And a quick thing that I think I forgot to tell is that when you rotate the vector, this vector, we are not considering that vector right now. We are only considering these two vectors, right? And let's create a paragram out of these two vectors. So I'm going to copy that. I'm going to move that right over there. Copy this, move it right over here. Now we take these two vectors. Let's change the color to orange. Let's do this. Let's make it dotted as well, and let's reuse. So we have this, right? So the resultant is gonna be this gray thing, which I'm gonna turn red pretty quickly. So this red vector is the answer, right? Also, we know the angle between vector a and vector b is gonna be theta, and this line is gonna be 180 degrees, which means this angle is gonna be 180 degrees minus theta, right? So, and also since we are measuring the angle with a, so I always did it with a, so I'm also gonna do this with vector a. So this is gonna be phi. So to make this much more clear, let's move it around here. Let's remove this one. Let's add phi, and let's add another one like that, right? So this is the thing that we must know, and the resultant, this resultant is basically vector b minus vector a, right? You can also call this vector r. So this and this are equivalent. So using the same thing, so let's say we have to find the resultant. The resultant is gonna be square root of a squared plus b squared plus 2ab cos 180 degrees minus theta, right? So this is just gonna be a square plus b square minus 2ab cos theta. So that's the magnitude. I think that's pretty clear. So let's put this in the box, even though this is a formula that you must have already known. And by similar way, you will find that the value of tan phi, so tan phi is also gonna be b sine theta by a minus b cos theta, by similar logic, and by the similar logic that we did for the first one. And let's put this in the box as well, even though we already put this in the box, but let's put it again. So, and also let's quickly summarize what. So here phi is the angle made by vector b minus vector a with minus vector a. So this is a point that you must know. This is the angle made with minus vector a. So if there is a question to find with vector a, you need to find this angle, right? So don't get confused. So there will be questions that this is the angle made with minus vector a, whereas this is the angle made with vector a as well. Okay, that's a quick thing I think I should have pointed out. So that was the first note. Now let's talk about a second note. So a second note that we're going to talk about is we're going to talk about a few properties. So vector subtraction doesn't follow commutative law. So commutative meaning you can move the terms, so you can't move the terms over here. So it will be much more clear once I show the law to you. So this means, let's say we have vector a minus vector b, and this is not the same as saying vector b minus vector a. It's very different. So that's what we mean by this is not commutative. So I think this is very clear. But if you're doing vector addition, both of them are commutative. So vector addition is commutative. So but also vector a minus vector b is same as minus vector b, like this. So you can take out the minus and this will be correct. So if you keep the minus, it will be correct. And also the magnitude of a minus b is same as the magnitude of vector b minus a. So I would say these 3 points are also very important for you, because at first glance they might not seem that important or logical also, but once you see the proof, it's like, yeah, that's true. So let's get both the resultant, since I did not change the dimension. So this is the first resultant and there is another resultant. So we are just doing this for our sake to check if this is true. So as you can see, the length are the same, right? They are of the same length and they are exactly 180 degrees apart. So keeping a minus would give you the same answer, and the lengths of the magnitude are also same. So that's what I'm trying to say. Maybe not exactly the same, but it's very, very close. So let's create this just for let's say if you want to see it or if you want to know. So let's change the color of this one. Let's see, this one is b minus a. So this resultant is vector b minus vector a, whereas this one is vector a minus vector b. And let's also keep the vectors a and b for someone to see like what we wanted to show them. So this is vector a and this is vector b, and we can show it like this because of parallel transformation. We could have moved everything anywhere and it does not matter. So I'm going to move vector b as well. So this is vector b. So this was our second node. Also we have a third node. A lot of nodes in this video. So the third node is going to be a vector changes when it is rotated, when it is rotated through any angle other than the multiples of 2 pi. So 2 pi is in terms of radians. So this is you generally don't need to keep or you keep a small c like that, so that's for radian, and on 2 pi radian is actually 360 degrees. So if you want to write that out, it's going to be pi is going to be 180 degrees. So pi in terms of radian is going to be 180 degrees, and so that's something that you have to know. To understand this, let's also take something like this, a vector. No need to name this since this is not that important to name. So let's say this is at 0 degrees. We are just going to take a bunch of 0 degrees or 0 radian. So 0 radian. Now let's rotate this. So let's take that, let's rotate this to be around I actually fact checked this, and I was thought that 2 pi radians would be written like 2 pi and the c, but in actuality I did not see anything that that this mentioned. So I think that's wrong, and I also checked and it told me that it was wrong. So you just write it 0 radians. So you can write rad, you can write radians, or you can just write 0. Anyway, it's fine. Let's just take a few other cases as well. Since pi is 180 degrees, let's say if we need 60 degrees, so 180 it's gonna be 60 degrees is 180 by 3, right? So 60 degrees, and let's also try to rotate this to make it like 60 degrees. So this is gonna be 60 degrees with respect to this line, and this is gonna be pi by 3 radians. You don't need to write the symbol, I just told you that. Let's try something else. Let's try 90. So this is gonna be 90 degrees, and let's think about how many times. So 180 by 2, so it's gonna be pi by 2, right? And now let's rotate this by 180 degrees. So if I rotate this by 180 degrees, it's gonna come over here, right? So this is 180 degrees rotation, and which is pi radians. And let's say if we rotate this again to by 180 degrees, or rotate this by 360 degrees, you get this, right? Let's match it so that it's of equal size, since they are supposed to be the same. So you get this, right? So this is 360 degrees, which is 2 pi. So also let's rotate this twice. So we're gonna rotate this again. So let's take this, I'm gonna copy this. Let's say 1, 2. So we rotated this by 4 pi radians. So this is rotated by 4 pi radians, and 4 pi is gonna be 4 times 180, which is gonna be 4 times 180, I think, which is 720 degrees. So this is gonna be 720 degrees, and so on. So as you can see with this one, so let's make arrows rather. This one, this one, and this one, we see no rotation, right? So that's what we are trying to say in this note. Finally, when we are the last note that I'm going to talk about in this video is gonna be when the word change. So when the word change is asked, it refers to subtraction. So this is something that you must know. Whenever not always, but generally when change is mentioned, it is generally about subtraction. So it's a general case, not a always case, it's general. Okay, so generally this is the case, but most of the time this is the case. So yeah, this is gonna be it for today's video. Nothing more to talk about for today. From the next video onwards, we are gonna do a few questions again. So we are again gonna go to the question ready. So I hope that was enjoyable for you. I don't know if it was, but that's it for today, and see you in the next video. Bye bye.